What's going on, guys? Let's try this problem right here. Here what we are going to do is we are going to use nodal analysis method to find out the unknown voltages. Now to do that one, what we have to do is we have to follow all 7 steps. The first step is find a reference node with known voltage. So for this part, the best thing to do is we connect the bottom part to the ground. So here if you connect this one to the ground, this is going to be 0 voltage, right? So we don't have to worry about the bottom part anymore. Now the next thing is assign voltage to the other nodes. So here we have 2 other nodes. So this is, we are going to put something like V1, V2, right? And that's it. And then assign currents to each branch. And this branch we have current, so we don't have to worry about this one. And this one, the top part, we don't have current, so let's put I1, right? I1 right here. And this branch also doesn't have current, so we can put I2. So it doesn't matter which direction you put, because if you assume the wrong direction, you are going to get a negative answer. Now here we have the current, and this one we don't put current because we don't have a resistance. So we only put the current when we have resistance in between, right? So we don't have to put the current right here. So for this one we have to put, let's put I3, and for other one we already have the current, so we don't have to put it. That's it. So let's go to the next part. Next part is apply Kirchhoff's current law to each node. Now Kirchhoff's current law is whatever the current enter must exit. Now here, this question is a little bit different than the other questions. Like when you have voltage source, here we have a voltage source in the middle. So when you have a voltage source, you have to deal with problem differently. So what you have to do is you have to create a super node. Like we have to take this whole part together, like super node. Let's choose a different color. Right. So what we are going to do is we are going to use Kirchhoff laws to this supernode. So here the thing is, whatever the current enter to this supernode must exit. So from that one we can create an equation. So this is first step, right? So the current entering to this supernode is 2 ampere. So we put 2 right here, and the current exiting from the supernode, it's I2 and I3. So this is going to be equal to I2 plus I3, and that's it. And also we have a 7 ampere, so we put plus 7 ampere. And we have created the Kirchhoff current law. Only one equation is there, right? And then the fifth step is define each current using Ohm's law. Now we know that Ohm's law is equal to V is equal to IR, and we are going to define current in terms of this one. So I is going to be equal to V over R. Now let's go ahead and find this one for each current. Let's start with I1. I1 is starting from V1, right? So wherever I start, that's going to come first. So since it's starting from V1, we put V1 first. So it's actually higher potential to lower potential, right? So V1 minus V2. And the resistance in between, that is 10, right? And then I2 starting from V1 and ending at 0 because we connected this one to the ground. So this is going to be 0. So this is going to be V1 minus 0 over the resistance in between, that is going to be 2 ohm, right? And then the third I3 is going to be here, starting from V2 and going to 0. So this is going to be V2 minus 0 over 4. So these are 3 equations we have. Now let's follow the next step. Substitute the current definitions into the node current equations. So what does that mean is we have to substitute these voltages instead of this Kirchhoff current law equation, right? Like I2, I3, instead of I2, I3, we plug these voltages. Now let's do that part. So this is going to be 2 equal to, instead of I2, I plug this V1 over 2. So this is going to be V1 over 2. And then instead of I3, I plug V2 over 4. plus V2 over 4, and that's it. So this is only current equation, and also we have a plus 7 right here, right? Now the next thing we have to do is we should try to get rid of these denominators. To get rid of this denominator, what we can do is we can multiply this one by the common denominator. Here we have 4 is the bigger number, and this can be treated as common denominator, right? So if you multiply this equation by 4, all the denominator will cancel and you will get a good equation, right? So this is going to be, we multiply this one by 4, and that's going to give us 8, and this is going to be 4v1, right? 4v1, and this is going to be 2v2, and 7 times 4 is going to be 28. So this is the equation we have. Now let's rearrange this one. So here we are going to have 4v1 plus 2v2. I bring the numbers to the other side, so 28. So if I bring the 28 to the other side of the equation, that's going to be minus 28 plus 8, that's going to be equal to minus 20. Now we have a good equation. Now we can use this voltage source to deal with problem easily. Like if you notice here we have higher potential because plus sign is in this side, and V1 minus sign is in the other side, right? So we know that higher potential minus lower potential is voltage drop. That's going to be equivalent to 2 voltage. So from this one we know that V2 is going to be equivalent to 2 plus V1. Now we can replace this V2 with this value. So in this way we only have one unknown variable, so we can solve this problem easily, right? So this is going to be 4v1, and if you multiply this one by 2, so 2 times, let's put this one, 2 times 2 plus v1 is equal to minus 20. Therefore 4v1 is 4v1 plus 4 plus 2v1 is going to be equal to minus 20. And from this one we know that 5v1 is going to be equal to minus 16. Okay, let's see. It's look like there's a mistake. So first we have this is v1 over 2, right? So 4v1 2v2 is equal to minus 20. Okay, let's check whether our previous solution is correct. So first we had 2 is equal to v1 over 2 plus v2 over 4 plus 7, right? And if we multiply this one by 4, that's going to give us 8 right here, and this is going to be, okay, this one should be 2v1, and this is going to be just v2, right? v2 and 7 times 4, 20. Now it's right. Now let's get rid of these things. We need this part anyhow, right? Now let's simplify this one. So again we are going to move the number to the other side. This is going to be 2v1 plus v2 is going to be equivalent to minus 20, and now we are going to plug this 2 plus v1 instead of this v2. So this is going to be 2v1 plus 2 plus v1, that's going to be equal to minus 20, and here we are going to have 3v1, and if I move this 2 to the other side, that's going to give us minus 22. Therefore v1 is going to be equivalent to minus 22 by 3, that's going to give us minus 7.333 voltage. Now since we have v1, now solving v2 is easy, right? All we have to do is add 2 to that, and if you add 2 to this value, that's going to give you 2 plus minus 7.33, and that's going to give us 5.333 voltage. Now we have v1 and v2, and if you want to find the current, you can go ahead and find it. It's very simple, like we can simply substitute values, right? So here we're going to have minus 7.333, and minus minus, that's going to make this one plus. Okay, this should be minus right here, because minus plus, that's going to make this one minus. So this is going to be plus 5.333 divided by 10, and if you calculate this one, you should get negative 0.2 ampere. And here we are going to have V1, that is negative 7.333 voltage divided by 2, and if you do that, you will get negative 3.667 ampere. And for the third one, it's V2 over 4, right? V2 is what? 5.333 voltage divided by 4, and if you calculate this one, you will get 5.33. okay, so this gonna give you negative 1.333 ampere, because this is negative. And that's it. This is how we do this kind of problems. I hope you guys find this video helpful. See you next time.